ZA array vector. ZA array can be accessed as vectors of SVL bits by accessing them as the ZA with an suffix n, where n will determine the number of the row that we can access within the ZA storage. So ZA array can be accessed as a vector of SVL bits. If your SVL bit is say 128-bit implementation, then we can use ZA0 to access the ZA0 row of that particular ZA array. Or we can access them as a byte or half word or single word or double word or quad word. That is, you can access the data in ZA array as an 8-bit element or 16-bit element, 32-bit element, 64-bit element or 128-bit element in that particular ZA array. Based on the access of the elements size, you can express them as B, suffixed with the number of the row that you want to access. That gives us access to that particular row in the ZA storage array. B suffix is used for 8-bit element size in that particular ZA array vector. H is used for 16-bit element. S suffix is used for 32-bit element size. D suffix is used for 64-bit element size. Suffix Q is used for 128-bit element size in a ZA array. How does it look? Here is an example of how an ZA array can be accessed for 8-bit element size. Here we have considered an example of 128-bit implementation. The notation that can be used to access byte is B. So we have this suffix ZA.B. The N will indicate the number of the row that you want to access. The whole thing is a ZA array vector. Here it is a 128-bit implementation, so it will be about 8-bit element size. We'll be accessing them as ZA.B. So we will have about 16 elements. And the ZA array size would be 16 by 16. Okay, each small box determines the 8-bit element. Now, what should I use to access this particular row? That will be ZA. I want to access it as byte for 8-bit element size, and my n will become 1. My n would be 0, 1, 2, 3, 4, 5, likewise until 15. So depending upon the vector that I want to access, my n will change. For ZA.B0, I will be accessing the 0th row. Similarly, for other ZA array vector access, I will be using the appropriate number, the suffix n, that will change. ZA.B7 will give me access to the 7th row. The rows being numbered from 0, this will be 7. Likewise, B1 will access the 2nd row, P2 will access the 3rd row, P3 will access the 4th row. This is for the 8-bit element size. What happens if my element size changes? Well, as we saw earlier, if the element size changes, say for example, instead of 8-bit, I use a 16-bit element size, then my first element will be here. So the number of rows, the 2 will merge to become 1 row. And instead of 16th row, I'll be having 8 rows here, if you name it from 1. This is a example of the complete namings for accessing a different ZA array vector within a 128-bit implementation for 8-bit element size. This is just added for reference. You can always refer to it for clarity. Let's see how the ZA array vector access will happen for 16-bit element size. It is just similar to 8-bit element size access, just that for 16-bit element size, instead of B, we will suffix .h. For 8-bit element, it was ZA.B. Here it will be ZA.H. The number of columns that you can observe it has been changed now because it is a 16-bit element size. However, the number of rows remains constant. Okay, now each small box here represents a 16-bit element. So ZA.H 0 gives me access to the first row of the ZA array storage. So there is a simple access where the ZA array can be accessed as a complete ZA array vector. This is for 16-bit element size. H6 will give me access to the 7th row in the ZA storage. H15, the suffix 15 here, will give me access to the last row in the ZA storage. Similarly, for 32-bit element size, we will have the suffix S, meaning single word access or 32-bit access. What we need to observe is the number of columns, because it is a 128-bit implementation and we have 32-bit element size, the number of columns has been reduced to 4 now. 128 divided by 32 gives you 4. That is because we have chosen a 128-bit implementation as an example here. However, the number of rows will be 16. So S5 will give me access to the 6th row when the naming convention starts from 0. This will be the 6th row, which is accessed as S5.